Alright guys, so this is going to be kind of my video tutorial working through some of your test review questions. I'm not going through all of them in this video, so I'm going to go through one of each kind of like we did in class. So then you guys can fast forward, you can pause it, you can rewind and go back and see what I said. Bear with me on this video thing. I'm trying to work through, this is my first time using this program, so it might get a little dicey at times, but we'll make it through it. But I've picked specific questions. We're going to do some solving ones. We are going to do a slant asymptote one and a couple of these sketching ones, okay? Making sure you know those characteristics, you remember your steps for solving, all that stuff is key. Like I said, you guys need to make flashcards. There is a ton of information on this test that you have got to know, and it's up to you to know it, okay? We'll have tutoring tomorrow, on Wednesday, and on Thursday as well. So you guys got to work hard with this one. I know it's a lot of information, but that's why I really wanted to make sure we had this video. So if you, for some reason, can't make it to tutoring, you can refer back to this, okay? Alright, let's go ahead and get started. So now, the first question that I want to make sure that we start on is going to be the solving questions, okay? So, the first solving question I have is right here, and it is irrational equals to irrational. If you notice, this is number 1 in the solving session. By the way, that's what the big one is. This does not have adding or subtracting, so this is the fun one where I get to go ahead and just do what? Cross multiply, okay? So when I cross multiply, it doesn't matter which side I start with, but I'm going to be doing x minus 2 times x plus 3, ooh, this is hard to get used to, is equal to 24. This one's nice because I do not have to worry about finding your least common denominator, all of that. Ooh, and before we do that, I remember, still got to find those domain restrictions. That will be a point on your test, and look, I'm already breezing over it. So x for sure cannot equal 2. So if we get a solution as 2, it cannot work. So here, I went ahead, cross-multiplied. On the left side, you see you have a binomial times a binomial. I am going to have to do the box in order to multiply this. Or if you guys know how to FOIL, you can go ahead and FOIL as well. Either way, I'm good with that, okay? We'll go ahead and do the box. So if you do your box, on the outside, you'd have x minus 2 and x plus 3. So right here would give me an x squared, negative 2x, a 3x, and a negative 6. So if I go ahead and we notice right here, these are like terms, I can go ahead and combine those. That would give me x squared plus x minus 6 is equal to 24. Alright, so now, notice that we have an x squared. The only way I can solve for x is I'm going to have to factor. You guys kind of have two routes that you can go. Either you can go ahead and solve for x if you don't have an x squared, but that big key or your big factor in your head is you should see, oh my gosh, I have an x squared, I'm going to have to factor. So that means I'm going to have to set this whole problem equal to 0. Okay? When I do that, that gives me x squared plus x negative 30 equal to 0. Now I can go ahead and factor. So I want to know what multiplies to give me negative 30 and adds to give me 1, because that is my b. So in this case, it's going to have to be 5 and 6. And in order for it to be a positive 1, it's going to have to be a positive 6 and a negative 5. Now, I just need to solve for x. Set both of those factors equal to 0. That will give me 5 and negative 6. Again, we've got to check these domain restrictions. Neither of my solutions are my domain restrictions, so that means they work and are for sure my solutions of my equation. If one of those happened to be the domain restriction, then it would be an extraneous. We'd have to cross it out and say that only one of them was the solution. Okay? So, moving on, the next couple ones. You will have one where it is a kind of, I don't know, not a rational, not a whatever. It's going to be like one of these where you have an addition. So on this one, we cannot just cross multiply and hope our troubles are over. Here, I'm going to have to check all my denominators, factor them if I can, take out a greatest common factor, and find, in this case, my LCD, okay? Oops, sorry, I went the wrong way. Still going the wrong way. Oh gosh. Oh god, I told you guys this would be a nightmare. Alright, here we go. Let me get the pen going. So, we've got to find an LCD. That doesn't really look like a D. Bear with me there. Okay, so the first one, 1 over x plus 2. There's not much I can do with x plus 2, so I'm going to keep moving on. 3 over x. Nothing I can do with x. Here, the denominator in this one has a greatest common factor of x and leaves me with x plus 2. I'm going to go ahead and keep x squared plus 5x the same, because I might have to multiply him by something, so I don't want to go have to factor and undo what I already did. So looking at these LCDs, they have a couple of things in common, and so that's our job, to see which one is our least. If you notice, this one and this one both have an x. So definitely x has to be part of my LCD. Also, we've got an x plus 2 and an x plus 2. Those are all that they have in common, so that has to be my LCD. Now I'm going to go ahead and find my domain restrictions. If I set both of these equal to 0, x cannot equal 0, and it cannot equal negative 2. So neither of those can be my solutions once I've solved for x. Now, I like to go ahead and bring down my numerators. My job is to cancel out these denominators, and the way to do that is to multiply the numerators by whatever they are missing from our LCD. Again, our LCD is x times x plus 2. So looking at the first numerator, and his denominator is x plus 2. He is missing just an x from our least common denominator. Now, moving on to the 3. He just has an x in our denominator, so he is missing the x plus 2. Okay, so I'm going to multiply his numerator by what his denominator is missing. And then the last one, equal to, the x squared plus 5x plus 4 is actually a numerator of the least common denominator. So he does not have to be multiplied by anything. He is going to stay how he is, and we are going to leave him alone. So let's simplify. We've got an x. 1 times x, just going to leave me with x. Got to distribute this 3. Will give me 3x plus 6 is equal to x squared plus 5x plus 4. Now, some bells should be ringing in your head. We have an x squared in this problem. So that means I'm going to have to factor. So I'm going to move everything from the left side to the right side because I don't want that x squared to become negative. Before I do that, these are going to be combined to become 4x. So I'm technically going to subtract a 4x from this side onto this side. And it only can combine with its like term of 5x. And then I'm going to subtract the 6. So this side should be 0, so we should have x squared plus x and then minus 2 equal to 0. So I've gotten down to everything combined to one side. I'm only left to factor. So I want to know what multiplies to give me negative 2 and adds to give me 1. The only factors of 2 are 2 and 1. And in order for that to be a positive 1 on the inside, I've got to add 2, subtract 1. So that will give me x is equal to -2, comma, +1. Before I circle that, I've got to look back up at my domain restrictions. What do we notice is a domain restriction? -2, correct? So that means that this guy right here cannot be a solution. He is one of my domain restrictions, so he is therefore extraneous. So my only solution is 1. So I need to make sure you guys understand you've got to show me those steps, okay? You got to show me all of that stuff. Show me the extraneous so I know it does not work, and circle the only one that does, okay? All right. Next question. Number 6. So here, same difference. This one has an adding between two rationals, so I can't just cross multiply. I don't have one rational set equal to another one. So my only option is to find your LCD and go ahead and find your domain restrictions, all that good stuff. Multiply the numerators by what its denominator is missing from the LCD. In order to do that, we're going to have to factor and take out greatest common factors if we need to. The only denominator that needs to be factored is the one 2x squared minus 9x minus 5. Now, look at the other two denominators. Those should be your very big hint about what that quadratic should factor become. So I want you guys to check it. Remember, you have a leading coefficient of 2, so you can't just take your shortcut. You're going to actually have to do the bottoms up method or put it in the box to factor it. But when you do, you should get 2x plus 1 and x minus 5. Okay? So my LCD is everything they have in common, which is just going to be 2x plus 1 and, oops, come on, x minus 5. Where x cannot equal -1/2 and 5. All I did was set those equal to 0. So, bring down my numerators. The 1, he is missing 2x plus 1 in his denominator. The numerator of 8, he is missing x minus 5 in his denominator. And the 1 is missing nothing, so I'm not going to multiply him by anything, okay? Brought down my numerators, multiplied them by whatever their denominator was missing from the LCD, okay? Now I'm just going to simplify. 1 times 2x plus 1 is just going to leave me with 2x plus 1. Here I'm going to have to distribute to give me 8x minus 40 is equal to 1. Now you can start moving things over, but I don't have an x squared this time, so I don't have to worry about factoring for once. Now I just need to solve for x, get everything away from x, and solve, okay? So I like to combine my like terms. 8x and 2x are going to give me 10x. 1 and -40 will give me minus 39. That's going to equal to 1. Going to add 39, cancels out, gives me 10x is equal to 40, right? Now, I divide both sides by 10, so x is equal to 4. Checking my domain restrictions, 4 is not either one of those, so 4 can be a solution, okay? So take your time. Do not let the silly mistakes of just combining like terms, stuff like that, kind of trip you guys up. That shouldn't be the hardest part of this, okay? You should be able to do this one. Alright, moving to the next one. I'm having a hard time moving to the next one on this thing.